So the principle of rectilinear propagation of light states that light ray can only travel in a straight line, and not in a curved line. So that's just the principle of the rectilinear propagation of light. And indeed, it is true from the following experiment. If you have this experiment to prove that light travels in a straight line, you have a tube, a long straight tube, and you have a source of light at one end, and you have your eye at the other end. You will be able to see the source of light, because light travels from the source of light through this straight tube and comes out into the eye. However, if the same tube, another tube, but this time curved, is used, you will not be able to see the source of light. Because light goes in here and it doesn't come out. If light travels in a curved path, it would have gone this way, and finds its way out. But because light can only travel in a straight line, so it goes here and it's obstructed here, and that's the end. Okay. Another experiment is this, the cardboard case. If we have this cardboard with a punched part, a hole, 3 of them arranged horizontally, and we have a hole on each. Now, if we have the source of light again, it passes through this hole, comes out from the other end, passes through the second one, comes out at the, and passes through the third one, and then comes out for your eye to see. But if the middle cardboard is tilted so that the 3 cardboards are not aligned, then what we have is something like this. The hole is here, the hole is here, the hole is here. Now, if the source of light is here, it passes through this hole, comes out, but it's obstructed here. So it doesn't come out from this second cardboard, the middle one, because of the tilting, they are not well aligned, hence your eye cannot see. These are experiments to prove that light travels only in a straight line. If light could travel in a curved path, it would have gone through this way and find its way to the next hole, then to the next hole, and out of the road to your eye. So this is an experiment to prove that light travels only in a straight line. The next thing we are going to do is the effects of this. The effects of this light traveling in a straight line. Or you call it the application of this rectilinear periodic. The effect is found in three things, three phenomena. One, formation of eclipse, formation of image, and formation of shadow. Three things: formation of eclipse, formation of image, and formation of shadow. So effects of the rectilinear, the principle propagation of light. The effects of this principle is found in the formation of one, shadow, two, eclipse, and three, image. Now shadows are formed on the background, eclipses are formed on the planetary body, while images are formed on the screen. Like when you snap a picture, the image is formed on the screen behind the camera. While eclipse, the image of one planetary body is formed on another planetary body. While shadow, the image of an object is formed on the wall or on the background. So that's the difference. But take note, for any of these to be formed, shadow, eclipse, or image, three things are required. One, source of light. Two, an opaque body. And three, a background. Source of light, an opaque body, and a background. And these three things must be aligned horizontally. So it's the obstruction of a light by the opaque body that causes the shadow, the shape of the opaque body to be cast on the background. Again, you have something like this. Yes, you have a body like this. This is your source of light. Usually what you do is, if this is the opaque body, this is how you draw this. It goes like this. Then this one goes like this. Then the other one goes parallel and parallel. So this is the background. Now, don't forget, light usually comes with arrow on it. Light ray. This is source of light. This is the opaque body. So this spot now is where the shadow is formed. This part is faint shadow. A faint shadow is found here and here. This is where we come to the types of shadow. We have the total one and the partial one. We have the umbra and the penumbra. Umbra and penumbra. So for shadow, eclipse, or image to be formed, the source of light opaque body and background must be aligned horizontally such that the opaque body must obstruct the source of light so that its own image is cast behind on a background. This is our shadow. So we'll be looking at shadow now. Shadow. A shadow is an area in which light rays from a source of light cannot reach. A shadow is an area in which light rays from a source of light cannot reach. You look at my hand now. You see behind my hand has obstructed the light from reaching this area. So the image of my hand of the shadow has been cast on this white board. So a shadow, why? Because my hand obstructed the ray of light from reaching this area. So the ray of light is reaching all other area except this part that my shadow is cast on. So that's a shadow. It is produced by the obstruction of light by an opaque object. Okay. For a shadow to be formed, like I said, including image and eclipse, a source of light, an opaque object, and a background must all be aligned horizontally for a shadow to be formed, including eclipse and image. A source of light, an opaque object, and a background must all be aligned horizontally such that the opaque object is in between the source of light and the background. Such that the opaque object is in between the source of light and the background. There are two types of shadow. One, the umbra, or so-called total shadow. And two, penumbra, also called partial shadow. The umbra is completely dark, it's a completely dark region. While the penumbra is light, is a light or gray area. Be formed at the same time when the source of light is large enough. Can be formed at the same time when the source of light is large enough. Look at my hand. If I put my hand very close to the board, you see only a dark part below. But once I bring it out, you see a dark part, and you see this region is faint, while this region is dark. So whenever the source of light is large enough, penumbra and umbra will be formed. Now, umbra is a region that is completely blocked. By the opaque object. It's a region where the source of light or the light ray is completely blocked. That's umbra. Completely blocked by the opaque object. While penumbra is a region where the light ray is completely blocked, is partially blocked by the opaque object. While the penumbra is a region where the light ray is partially blocked by the opaque object. Normally, if we have to draw this way, in real life, and we have something like this. Then we have something like this. And something like this. Please pay attention. Then we could have something like this. So this place is going to be completely dark. Now this place is going to be easy. So of drawing this out, it appears in red. So you see this trace of the partial will go round too. So this was absorbed. This is the penumbra. And this is the umbra. This is the opaque object. This is the background. And this is the source of light. So an eclipse is a shadow of an heavenly body, cast on another heavenly body. An eclipse is a shadow of an heavenly body, or of a heavenly body, cast on another heavenly body. It is as a result of the alignment of the sun, the moon, and the earth. It is as a result of the alignment of the sun, the moon, and the earth. See, when you know that the moon is the satellite of the earth, so the moon is revolving around the earth, while the earth is also revolving around the sun. So let's assume that this is the sun, the earth is revolving around, and the moon is revolving around this earth too. Let's assume when the sun, the earth revolved and got to this place, that was the same time the moon revolved and got to this point. Do you see something? So we have something like this: the moon in between the sun and the earth. Whenever the moon is in between the sun and the earth, the shadow of the moon will be cast on the earth